introduce our first presenter, which is Dr. Jeff Lamondia. He's an assistant professor in civil engineering at Auburn University. He received his PhD in transportation engineering from the University of Texas at Austin. His research interests are in multimodal transportation planning, safety, travel demand modeling, and travel behavior analysis. His expertise is also in the development and application of discrete choice models. The title of his presentation is Public Transportation Education Course Module. With that, Jeff, go ahead and you may begin.
Great. Well, good morning, and thank you for that introduction, Inez.
You're welcome.
I am Jeff Lamondia, and I have to say that this project is not just me. There are folks from Georgia Tech and now City College of New York who were involved in developing this. So Carrie Watkins actually is the lead researcher on this project, and Candace was a PhD student at the time when we developed the materials. She's now a assistant professor at City College, which is great. And of course, we want to thank Stride very much for supporting this. We think this has been a great endeavor, and we've gotten some great feedback already from it. So thank you for the opportunity. So the motivation for why we've been working on this project has to do a lot with the growing interest in transit, and not just in the civil engineering field, but many other engineering fields and other disciplines outside engineering. And the idea that we took with this was it's important for people to understand the basics of transit and public transportation, so when they make decisions, whether it's in that field or just related to it, they'll be able to make better decisions and support the transit, whether directly or indirectly. So there's not a lot of this transit course materials available at different universities across the country, so we saw this kind of niche as an important one that we needed to fill. And I'll be talking a little bit today about two sets of information that we developed that are available for anybody across the country, across the world to use. We have undergraduate course materials and graduate course materials. The undergraduate course materials and they're both very different sets of information because we felt they were different audiences that needed to grasp different sets of information. So the undergraduate course materials are designed to be kind of a week-long course supplement intended to be sort of added to an introduction to transportation engineering course or an introduction to civil engineering course. And it has 3 unique modules that you can kind of pluck and choose and move around. I'll talk about them in more detail. It includes some readings and an assignment if professors are interested in using something like that. The graduate course materials, of course, are much bigger. They represent an entire semester course. And they have 20 different modules that make it up, and I'll talk more about what's involved in those modules. And since it's an entire course, it includes many more readings, many more class activities, which again I'll talk more about, and some assignments that work through it. And then there's this little box here that I wanted to highlight. Kind of our overarching motivation for this was all of the different modules we came up with include slides and information for practitioners and professors to use, but they include a lot of background information. So if you're preparing this to share, you don't necessarily have to know a lot about transit before going in to share these with students. So we provide a lot of that background information to give you the information to use for this. And the modules themselves, whether you are using the undergrad course or the graduate level course, it can be kind of a la carte, where you move stuff around. Or if you find that, I only really just need information about fare design, then you can pull that bit of information and use it specifically in your course. Well, where we got all this information from, we didn't just figure what we thought was interesting. We went to the source, and we went to academics and to practitioners, and we talked to people that we knew had either a full transit course or incorporated something about transit in their courses, and gathered syllabi and all their course materials. So we had a massive database of their information. And we also went to practitioners who didn't have this material, but we designed a survey to ask them about which topics they thought were important. And you can see here the different groups, predominantly around the southeast region. That's where we have a lot of our contacts. But we did have a lot of people from around the country, including Washington, Connecticut, Vermont, Ohio. So it's kind of well represented. and the results were consistent across the country. What you see here are the top 10 topics from each of the different perspectives. And we found this really interesting, that across the two, the blue highlighted ones were the only topics that are consistent across both academics and practitioners. And I guess I can go to the next one. The idea behind the academic perspective was that the information they were sharing was very design-oriented. They went to the basics, they got to the root of everything to give you that background for all the design questions. The practitioner perspective, on the other hand, was doing more planning-oriented, where they wanted bigger scope of what was going on and wanted to know how to connect the transit programs into the rest of either the city plan or a regional plan. So that was very interesting, and we realized that we needed to incorporate both of these together, which brought us to these objectives. We realized that we needed some planning, some design, and operation, and tie them all together, and a balance between both the academic and practitioner expectations. And really the key thing here was that we wanted to have students or whoever's learning this information be able to understand the basic concepts of how to build a transit system and make those decisions, but also once one is operating, how you can make it more efficient, more effective, and kind of go in and improve the planning side of that operating system. Well, let me tell you a little bit about the different course materials we developed. The undergraduate course materials, as I said, have 3 different modules, and you can see these are some of the slides we developed. There are notes that accompany these slides if you're interested in using them. And the 3 topics that are covered are selecting transit modes. We talk a lot about how to characterize different modes, and the idea here is that it's not one size fits all, that you're going to pick a perfect transit mode for your situation, and we teach you the skills of how to do that. The second module we cover is improving transit service through planning, design, and operations. This is kind of a crash course in how to do all the big picture things of operating a transit system. And then at the end, we have a group application exercise, and this has been really successful with our courses that we've introduced this. It uses the information from the previous 2 modules to apply, and that's actually what one of these pictures shows. Is it's in Jackson Hole, Wyoming. We take them and show them the current system that exists there and give them a bunch of information about where people are moving around the system, kind of high-level planning information, and give them an opportunity to develop the system using the information they've learned in the previous 2 modules. And we have a little discussion at the end to compare and contrast between different designs that groups have come up with. It's been a great feedback. And I should say that we've introduced this both at Auburn University and at Georgia Tech University, but other folks across the country have introduced this as well, including City College, the University of Connecticut, folks up in the University of Washington, and so forth. So we've gotten good feedback, and we've gotten information back about the little quiz we do at the end, and it seems to be very effective at getting the information across. Now, the graduate course is much bigger in scope, and it includes many more topics. Now, the 20 modules that are included with this one are not listed all here. What I've shown you are kind of the major overarching topics that the modules make up. So there's multiple modules that fill in each of these different topics here. And you can see that it covers much more of the design, getting into the nitty-gritty of how a system is built from the ground up, and then once it's running, how you're going to improve, for example, the ridership and forecast how that's going to change over time. So it incorporates a lot more. And you can see 2 of the slides that we use here, much more data-driven for what's going on with the graduate course materials. And because we're spending an entire semester doing this, we have many more in-class exercises. You can see the picture on the top shows that one. That's the Paris transit system. And we talk about how, in that example, the region is laid out and how different types of lines support different types of development. So lots of different examples and exercises that we incorporate in here. Along with the graduate seminar information, we have many different, we call them homework assignments, but they're really hands-on projects where throughout the semester students get to ride transit systems or use existing data from transit systems to answer many of these different topics and questions that they're taught during the seminars. So it's a nice way for them to experience what's going on with real data and real hands-on applications. Now, in both of these, we use a number of different course readings that are open source, including Jarrett Walker's blog, which has been turned into a book, the TCQSM, the Transit Capacity and Quality of Service Manual, and of course the APTA website and database from there. So everything that we've done is open source, doesn't require students to purchase anything. And then we've added on a number of things to the curriculum, which we've found successful, not necessarily part of the materials we developed, but are included in that material as recommendations. As I mentioned, we have our hands-on examples, the homework problems. We've had guest speakers come in. For example, at Auburn, we've had Wiregrass Transit, which is from the southern part of the state, and is a demand response transit system, come in and talk about the challenges of operating that system, which was greatly received. We've done field trips. We've gone to the MARTA systems over in Atlanta. And that picture is from my students that are over there getting a tour of the maintenance yards. And we do course projects where at the end of the semester students take everything that they've learned and do some practical applications. For example, this year we're working very closely with Tiger Transit, which is the transit at Auburn, to kind of improve the data collection of ridership and helping them out with that. And I wanted to show you this little chart where we thought, you know, the things that we've developed in this survey, or in this series of modules, is not just appropriate for civil engineering. It may be great for our course, but you can apply it to lots of other things. So we defined how these different modules can be applied for other things like environmental science or operations research, to incorporate these ideas behind transit into other fields to help kind of promote this across the board. And lastly, I just wanted to point out that you can download all the materials that we have right now at the Stride website, and that's what this link is up on top here. So you can jot that down. But if you have questions or want further information about any of the materials, please feel free to contact Carrie or I. We love talking about this, and we're constantly improving the materials based on feedback. So I will wrap up there, and if you have any questions, I'm happy to answer them.
Thank you very much, Jeff. If we have any questions for Jeff, please go ahead and type them in your the question and answer box and submit them, and I will read them back. Okay. Well, if no one, I don't see any questions being typed. Maybe they will think of them, and maybe at the end of the entire presentation anyway. So with that, we will proceed with Dr. Daniel Rodriguez, and he will be presenting on pedestrian and bicycle transportation course modules. Dr. Daniel Rodriguez, to let you know a little bit about him, and he's a distinguished professor of sustainable community design in the Department of City and Regional Planning at the University of North Carolina at Chapel Hill. He also directs the Center for Sustainable Community Design, and he's an adjunct professor of epidemiology within the University of North Carolina at Chapel Hill. His research area focuses on the reciprocal relationship between the built environment and transportation and its effects on the environment and health. He has many publications, authoring more than 70 peer-reviewed publications, and co-authoring the book Urban Land Use Planning by the University of Illinois Press. With that, Dr. Rodriguez, I will transfer it over to you.
Yes, Ines, thank you very much. Good morning, everyone. And my presentation is an excellent segue to the presentation of Jeff. We'll be talking about a set of modules that we developed about 2 or 3 years ago, really 3 years ago. But I'll highlight also some updates that have been occurring that are wonderful news for this set of modules. So we developed 3 different modules that I'm highlighting here. Planning for pedestrians and bicycles. I'll go into the details in a minute. Pedestrian and bicycle facility design, and pedestrian and bicycle data and performance analysis. We do have, as Jeff suggested, a link to these files through the Stride website, but we also have a link through this other website that is the Pedestrian and Bicycle Information Center. They both will take you to the same path, so to the same destination. So both paths lead to Rome. Of course, this was an effort that did not include me only. We have collaborators at Auburn, Rod Tarucci, and at PBIC at the North Carolina, Carl Sundstrom and Laura Sant played a pretty important role. So now you know where I'm going. What are those three modules? And I want to tell you why, what motivated us to do this and why it was relevant. According to the latest report by the Alliance for Biking and Walking, crashes involving bicyclists and pedestrians account for almost 15% of all the traffic crashes. And if you think about a region, the states that house Stride, so this is kind of an internal motivation, such as Florida, Alabama, Georgia, our own North Carolina, Mississippi, are among the top states with the highest fatality rates for pedestrians and bicyclists in the whole nation. So there's a regional impetus, and there's also, of course, a national motivation, because this topic is of national, if not worldwide, importance. The final motivation in this final bullet has to do also with the importance of training engineers and planners on pedestrian and bicycle issues. In fact, the curriculum subcommittee of ITE developed a list of competences, core competences for every transportation planner and engineer to have. And among 13 of their learning outcomes identified, 3 were very directly related to pedestrian and bicycle aspects: safety analysis, complete streets planning, design, and operations, and connecting driving and pedestrian experiences with terminology and classic transportation engineering problems. As a result, we really believe that training the next generation of planners and engineers to consider pedestrian and bicycle issues is critical for safety and livability concerns, and for creating a more balanced and integrated and efficient transportation system. So that's how we got to this topic. Each of the modules were guided by a set of principles that we try to follow as close as possible. As Jeff's, they were self-contained, so we wanted instructors to be able to pick one of them if that's what they wanted, or pick the 3 of them if that was their interest. They are 15 minutes long each, trying to fit a little better the undergraduate, the prevailing undergraduate time allocations, but not, of course, they're not universal. And we thought of them as being both customizable, so you could cut pieces if you wanted to not cover something, or emphasize others if you wanted to go deeper. But they were essentially turnkey, and by that I mean that we have the slides, we have a script that accompanies the slide, so the instructors can read the script and just get a sense of what that slide should be about, and a reading list provided as well. And the last module, Module 3, also contains an assignment, and so that's also helpful for those that would like to perhaps emphasize or enhance an aspect of the teaching. It's aimed at upper-level undergraduates in engineering and planning, and we think that the modules, and we've already tested these modules in master's students in transportation planning. So that's our audience. We also wanted them to be fairly easy to update, and in fact, as I'll tell you in a second, that's what we have been doing over the last 2 years. A little bit of who has been using them. We did an initial test with engineering juniors at Auburn. Jeff, thank you very much. So yes, you just heard from Jeff before. He was our leading guinea pig. He was very generous in helping us do this. And we refined them, the slides, as a result of Jeff's experience and what the students told us. And since we've broadcasted the material and put it out there to the public and disseminated it, we've had more than 145 downloads. If you see here on the left-hand side, predominantly non-university downloaders, but also university downloaders. So about 58 downloads from university-affiliated individuals. And we also asked them to download, what are you using it for? And the vast majority are using it for capacity building, training, teaching, 2% for advocacy, almost 10% for planning practice, and 11% for other purposes. So that gives you a sense of how these materials are being used by the downloaders for capacity building. So let me focus here on the first class, the first module. It's planning for pedestrians and bicycles. This was designed mostly as an introduction. The learning objectives were or are to identify the land use policies that affect our transportation choices, and specifically, of course, our pedestrian and bicycle transportation choices as users. The second one is to understand plans, and specifically here pedestrian and bicycle plans, as policy tools that can guide and help future investments and policies. Third is to recognize the challenges of implementing those plans and how one could work with state DOTs and with metropolitan planning organizations and municipalities to get the infrastructure built and the programming and the promotion in place. And lastly, to become familiar with strategies and challenges, particularly around having a robust pedestrian and bicycle planning program. The second course is more engineering oriented, if I may, and it focuses on pedestrian and bicycle facility design. Our focus here were to the students that go through this class at the end would be able to give reasons for designing for pedestrians and bicyclists, understand how the streetscape influences design, give examples of different roadway designs for pedestrians and bicyclists, give examples of different intersection designs, and think about opportunities to retrofit existing streets along the lines of a complete streets policy. And finally, our third class is more of an analytical class, less design, and it focuses specifically on being able to describe the data that exists, identify those sources of data, how could it be collected, understand possible analysis, for example, a level of service analysis, and calculate level of service for bicycle facilities. In the last couple of minutes, I also want to highlight those updates that I announced initially. We have been working with tool design in the development of a new assignment on the analysis of bicycle stress, and so this is going to come online very soon. We have also updated the reading list. As I mentioned before, our grant really ended in 2013, and this is a rapidly moving field, and so in 2 years there's a wealth of extra resources that have emerged. Among them, as this third bullet suggests, is the federal guidance for separated and protected bicycle lanes. And so we are right now improving that information and updating it in the materials. This will go also to Federal Highway Administration because this update is being funded by the Pedestrian Bicycle Information Center, but we expect it to be ready for the public by mid-July. And I would be remiss not to acknowledge the support that we received from Stride, which was wonderful, not only the funding, but also the support at the staff and management level. That was wonderful. Jeff, thank you very much again for your help with the testing of the modules and the reviewers. And again, this is the link where you can find the materials. So with that, I'll open it up for questions or any comments that anyone in the audience might have.
Thank you very much, Dr. Rodriguez. If you have any questions, go ahead and submit them in the question and answer box for Dr. Rodriguez. And also, I just want to give everyone a reminder that at the end of the webinar, you will find a link that will go to a survey. It's a very short 5-question survey, so if you could fill that out, I would really appreciate it. Okay, so while people think of questions, let's go ahead and go with Dr. Scott Washburn, who's going to be demonstrating a simulation program titled Signalized Intersection Simulation Program for Education. And Dr. Scott Washburn is an associate professor in the Department of Civil and Coastal Engineering here at the University of Florida. He served here on the faculty since August of '99. His areas of expertise include traffic flow theory, traffic operations analysis, traffic simulation and model development, testing, development of traffic analysis and level of service computational methodologies, and complementary software tools. He's a co-author of the textbook Principles of Highway Engineering and Traffic Analysis. His teaching background includes courses on civil engineering systems, transportation engineering, traffic engineering, freeway operations, and others. All right, Scott, go ahead.
Okay, thank you, Inez, for the introduction. Can you hear me okay?
Yes.
So I think the first order of business is to make sure everybody can view the program okay. And I think what we need to do, and Inez, you may need to remind me, so there's some settings.
Yes, if you go to your, if you go to the Adobe Connect screen, right where you see the Dr. Washburn's desktop, go to the upper right-hand side. It says Request Control, but there are 3 small boxes next to that in the upper right-hand side, next to the Request Control box. One of them, if you hover over it, says Scale to Fit. The other one says Zoom In, and the other one says Full Screen. You can click any one of those and your screen will be bigger and you will be able to see.
Okay, so hopefully while the participants are trying to set their screen setting, but if you get it in that full screen mode, then hopefully it'll be zoomed in pretty well on the software program.
Yes.
But, while you're working on that, I'll give you a little bit of background. This project was primarily motivated through my experiences in teaching the Introduction to Transportation Engineering class, and one of the modules that we cover in that class is signalized intersection timing and analysis. And this always proves to be a very challenging topic for students. It's often difficult for them to kind of visualize how visualize mentally how the signal operates. And of course, you can draw things on the board and try and illustrate the dual ring diagram and so on. When you finally turn them loose on an assignment to develop a phasing plan, for example, for a signalized intersection, they really seem to struggle with that. And the other thing is, again, with the analysis of signalized intersections, certainly queuing theory plays a very important role with that, visualizing the vehicle arrivals and vehicle departure process and so on. And just given kind of the current generation of students, a large majority of them are very visual and typically learn more effectively through hands-on exercises. So that was a major motivation behind developing this software tool, was to be able to have students work with this and more readily visualize how the intersection is working, and certainly be a safer situation for them than standing out by the side of the road and watching the lights change on the signal heads. So hopefully everybody has got their settings adjusted so they can see the software okay. So what I'm trying to do with this, those of you that have worked with simulation programs before may be wondering, okay, what's different about this, just another simulation program. But those of you that have worked with the likes of a Core Sim or a vSim or AIMSIM or Pavements and so on know that one of the biggest chores with that is actually setting up your network. And even though this is just a single signalized intersection, it still takes time to create that, to create your links and connect the links for the turning movements and so on. And that can be a somewhat tedious and a little bit time-consuming process. And when you're in an introduction to transportation engineering class, you really need to be focusing on the learning concepts and not having them spend a ton of time just trying to get a network coded and up and running. So this software tries to alleviate a lot of those headaches. And currently I have 2 intersection templates, and I plan to eventually expand that a little bit as time allows. But for this initial version, I have 2 intersection templates. So when you first load up the program, you'll see you have the roadway data section here on the left, and you have a configuration template. And so basically what you start with here is a 4-approach intersection with 2 lanes approaching in each direction. And in this case, there's no dedicated turn bays. For the second template, it expands upon that and adds a dedicated left turn bay for each approach. And eventually I'm going to add one that has a dedicated right turn bay as well, but it doesn't contain that yet. The third one actually will be disabled in the release version because that deals with actuated control, which will also be added in a future update, but it's not quite ready for public consumption yet. And as part of this, you can set the posted speeds for the north, south, and east, west direction. So you can't have each approach have a separate speed, but each kind of major direction, east, west, and then north, south, can have its own posted speed, and that will range from 20 to 45 miles per hour. Then in the pane in the center of the screen is the traffic data. So here you have some boxes where you can adjust your demand volumes for each of the turning movements at the intersection. One limitation right now is you can just do passenger cars. Eventually I'll have it so you can include trucks in that as well. And when you have those values set, then you can move on to the phasing and timing setup. So you click this button here, and that's going to bring up a separate screen. And so what the idea here is to again allow students to really more visually see how movements get assigned to different phases within the signal controller. And what I have illustrated up here is the dual ring, the standard dual ring diagram, and then below that are these timing stage boxes. And those of you that have worked in the signal timing area may not be all that familiar with the timing stage terminology, but Dr. Mike Kite out at University of Idaho, and I think he might be on our call today, has kind of been promoting this term. The term phase has been often inconsistently and confusingly used, and that doesn't help with students learning this material for the first time. So the idea here is to figure out, okay, what movements are going to move simultaneously, and those are going to be the movements that move at the same time are going to be grouped into these timing stages. So for example, we might start off with leading left turns on the east-west street, and then maybe we want to give a little extra green time, for example, to this left turn, and then we can start the adjacent through movement as well. Then we can add a timing stage, and then we can have the opposing through movements go, and then we can add some timing stages for the north-south set of movements. So we can click a timing stage there, and now we can do the north-south left turns. And again, we can add some green time for that southbound left turn and start the adjacent through movement. And then we could go to the opposing through movements. So the minimum green time doesn't come into play right now until I get the actuated timing control implemented. So this is just a pre-timed operation. You'll work with the max green, the yellow, and the all red intervals. And so we could change those times just a little bit. So again, these are the times allocated to the timing stages. But of course, this is not exactly how it's implemented within the timing controller. So once the students get their timing stage pattern figured out, then they can assign the times to the dual ring diagram within the controller by clicking this button. So now that's going to show you, how the actual green, yellow, and all red times are allocated to each of the phases within the dual ring diagram. Once you've done that, now you can save that to a file if you want, so you can open up later after you've closed the program and restarted it. But it'll be saved to memory regardless. So you can exit the form. Just a little warning saying, if you want to use this file later after you close the program, make sure you save it. So once you've got all your inputs specified, then you can bring up the simulation control panel. And you can change the random seed numbers if you want. I'm just going to simulate it for 5 minutes. Right now it's set for a maximum of 20 minutes. I'll probably eventually change that to 60 minutes. But for purposes of classroom use, 15 minutes will probably be sufficient. And then I can run the simulation. That'll take a few seconds. And that's done, and I can close that window, and then you can click on the animation button. Well, that'll load the animation window, and again, hopefully you can see this okay on your screen. I'll slide these boxes over a little bit to make that easier. So you have the animation controls up here. We can hit the play button. And so what you'll see also, again, is the dual ring diagram here, again, to help students visualize how the signal controller is actually functioning. And so it's going to indicate, which movements are in green and so on. Now, the movement of the vehicles may look a little herky-jerky on your screen. That's because of the lag through the Adobe Connect presentation system. One other thing that might be useful as well, but again, so you've got the lines here at the intersection, and those are correlating with the signal status. But you can also click on a vehicle if you just want to get a little bit more information about what its desired velocity is, its actual velocity, and so on. Just some good diagnostic information there. And I'll speed it up just a little bit because I think we're getting short on time. So you can run it at real-time speed or up to 10 times real-time speed. So there's that. And I know we're getting a little short on time, but let me show you the template one as well. Let me close that real quick. So the template one is the one that doesn't include the turn bays, particularly left turn bay. So that's a good situation to demonstrate the concept of a split phasing timing pattern. So we can go back in here, and now we can, so that, again, this is designed to warn the student. So one of the other limitations at the moment is it doesn't include permitted movements, but that's something I will add in the future. But if a student tries to add a conflicting movement, so again, you just click on the movement you want to add to the timing stage. So here they already have this left turn movement, so if they try and add the opposing through, it's going to tell them, no, there's a conflicting movement in this stage. It's interesting how many times in the classroom students try and combine movements that just can't be moving at the same time. Oops, I do want to remove that. We want to do a split phase setup. So that's going to handle our east-west movements. And then there's our northbound and our southbound movements. I'll just leave the standard timings there. Okay. And I'll just speed it up a little bit. So yeah, this is a good setup to demonstrate the split phasing concept where you're serving all the movements for a given approach in sequence. So yeah, I think we're getting short on time, so I'll try and kind of wrap it up there. I'm kind of at the sort of the punch list stage of this whole thing. Just a few little details, kind of polishing up here, and a few things with the outputs. There's a very detailed data file that's output that you can import into Excel, and you can do a lot of analysis on that. It gives you all the details for every vehicle, for every time step, and so on. But I'm working on kind of finishing up some overall summary statistics as well. I've already talked to a couple of you, but anybody else that I haven't talked to that's interested in doing some beta testing of this program during the month of July, please let me know. I'd be happy to get your feedback on it before we finalize it for the project requirements. So let me end there.
Thank you very much, Scott, for that demonstration. Do we have any questions? Okay, if you have any questions, make sure that you type them in the question and answer box, and I will read them back, and the presenters can respond. So next we have Dr. Wiston, who is an associate research professor at the National Center for Asphalt Technology at Auburn University. He received his PhD from Auburn University in 2009, where he developed fatigue criteria for perpetual pavement design based on measured field strains. As part of the National Center for Asphalt Technology, Dr. Willis conducts research on sustainable materials and quantifying sustainability. He served as a member of the FHWA Asphalt Recycling Expert Task Group and is now a member of the FHWA Sustainable Pavements Technical Working Group. He will be presenting on sustainable pavements. Okay, go ahead.
Thank you very much for allowing me to have a few minutes of your time today to talk about the Sustainable Pavements program that we're developing at Auburn. When we started working on this, our goal was to design really two things. One was a graduate level course which would teach students how to think about sustainability towards pavements, but also to develop information and technology transfer that could use for practicing engineers, because there has been a big push recently by organizations such as the Federal Highway Administration to start thinking about sustainability and how it really affects the field of pavements. But one of the things that we've realized the most is when people start thinking about sustainability, and many times we're all talking about very different things. I remember the first time that I ever really got into sustainability, and I went to a workshop here at Auburn University, and I came back. It had been out in the woods all day talking about how we were going to put sustainability into some of our courses, and my wife was, well, how was the Kumbaya seminar? Where she thought it was basically people just talking around figuring out how we were going to save the planet. And while there's part of it, sustainability is something that is so much more deep, and it challenges our not just our students, but our practicing engineers to really change the way they think and change the way they approach the world. One of the things that I think has been really interesting when looking about sustainability, and especially kind of when relating to our pavements, is that sustainability is really, it's a new buzzword, but it's something that's been around on this planet, or a concept that has been around for so long and is so deep ingrained in many cultures. One of the there was an old ancient Greek proverb that said, "A society grows great when old men plant trees in whose shade they know they will not sit." Kind of in the South, we ask the question, when's the best time to plant a shade tree? And the correct answer is 50 years ago, so that when you actually need to be in the shade, the tree is fully developed and you can enjoy it. What we're trying to do with the courses that we're developing are teach students to be very forward thinking, to look out 50 years into the future and figure out how are these decisions, how are these specifications and these concepts that we're developing as part of something as simple as a pavement structure affect the future and affect others. If we look at that word sustainability, the most common definition associated with sustainable development was written in 1987 from a UN document called Our Common Future, which was also known as the Brundtland Report. And it said it's development that meets the needs of the present without compromising the ability of future generations to meet their own needs. And one of the things that many engineers struggle with is some of them really like the idea of sustainability, but that sounds all touchy-feely, and what does that really mean? How do I do this? And especially when I'm thinking about urban environments or pavement structures and transportation. Well, after that, there were three fundamental components of sustainable development that were developed, kind of called the triple bottom line, where they looked at environmental protection, economic growth, and social equity. And it's really, when we look at the combination of these three things, we start to understand that without looking at the environmental, economic, and social side of things, we really don't understand if we're being sustainable. I was doing one of my technology transfer workshops actually for the Florida DOT a few summers ago, and I showed this document or this same slide, and the first question that came up from them was, is this Venn diagram to scale? Because sustainable development looked pretty big. In reality, one of the things that we have to teach the students and our engineers is, while people want us to be sustainable, really that's a lofty goal, and what we're trying to do right now is instill knowledge and desire to make better choices so that we can move towards this desired platform. In 2008, it was the first attempt to really ever define what a sustainable pavement actually was. Peter Taylor, in a document that he wrote, said it minimizes the use of energy, renewable resources, while generating a minimum number of pollutants in a most cost-effective manner while maximizing the benefits to society. So again, it started to incorporate those ideas of thinking about a pavement in terms truly of that triple bottom line and how each impact affected it. Well, as engineers and as the students get into this course, one of the things they want to understand is, well, how do I quantify it? How do I know if this is something that I'm doing? And so when we look at trying to quantify sustainability, from an economic side of things, we use ideals and teach things like life cycle cost analysis, where you understand over the life of the pavement what are the economic impacts, both good and bad, with the choices they make. From a social side of things, like most true engineers, we have no clue about anything social. We focus on the numbers, and we get really uncomfortable when we start talking sometimes about trying to quantify safety and lives and things from that nature. Then on the environmental side of things, we teach students how to conduct a life cycle assessment of a pavement, which is very different in many ways than what we would consider for a life cycle cost analysis. But life cycle assessment is a quickly growing field in sciences, and it's something that students need to be able to look at because it's even integrating itself into things like the current lead iteration. So the way that we approach the structure of this course is we look at kind of that life cycle of the pavement. What are the costs, what are the environmental impacts over that life? And we look at things from these 5 different phases. From the material side of things, like what does it take for me to get materials out? How does it affect my production, my transport? We look at what can we do to have better practices during construction, reduce traffic delay, and have better equipment on site. One of the things we commonly don't think about is, well, what goes on while the pavement is actually being used? Look at things like fuel economy and rolling resistance, lighting of the pavement, and how that affects energy demands and costs, and even get into a little bit of the urban heat island idea with pavement albedo. And then maintenance, preservation, rehabilitation, a massively growing area of study today, but how does that affect sustainability? And then at the end of the life, can you reuse the pavement? Is it left in place, or do I have to take it off, landfill it, and try to do something with it? When we look at the course, there are some things that we always did. We started off structuring this completely with 20 to 23 different modules which were developed for a graduate level class, which in many ways could be also then just transferred and plugged and played directly into a workshop or a day-long seminar for practicing engineers. When we developed the workshops, what we specifically did is we talked to the state DOTs and said, what topics are most of interest to you in your state? What's more relevant to you? Because sustainability in many ways is very regional, and it is not a black and white issue. It affects people differently in different parts of the country. But we always talked about just what is sustainability and why is it critical for us as pavement engineers. We looked at how do you conduct a life cycle assessment, and then we started getting into the details, looking at specifically material choices. What recycled materials are available to be used, such as coal combustion byproducts, reclaimed asphalt pavement, recycled asphalt shingles. We covered things both from the asphalt and the concrete side and figured out what materials are available, but maybe even more importantly, when are they appropriate to use. We looked at the production and construction phase of things, such as how do I improve the sustainability of my plant operations? When I'm compacting an asphalt mix, how important is density, and what kind of things like self-consolidating concrete are available to maybe possibly improve some of the way that we handle our construction. Then we got into the use phase, which is the highly debated and kind of highly researched subject right now, where we specifically looked at things like rolling resistance, pavement noise, urban heat island, and safety issues, such as using porous or pervious pavements to reduce hydroplaning and make the roads safer for us to drive on. And then finally, we did end talking about pavement rehabilitation maintenance and our end of life. Most of this material has been recently updated to include a lot of the guidance that's given in the new Federal Highway Administration document towards sustainable pavements, a reference manual. But one of the things that we strive to do with the way this course was developed and the projects that we had them do, such as conducting a life cycle assessment to designing a new sustainable corridor through the downtown Auburn area where they had to get business involved and city members involved, was to really think about things from that true triple bottom line perspective. How's this going to affect the environment? How's it going to affect the society or the community that I live in? And ultimately, is it economic feasible? Because all three of these things have to be a part of our choices and decision making when we are looking towards developing a more sustainable pavement culture. Thank you very much, and we thank Stride for their support and their funding of this work. At this time, I think we have a few minutes for any questions.
Yes, we have about 5 minutes for questions. Thank you very much, Richard. Do we have any questions for any of the presenters? You can type them in the question and answer box. And don't forget that we have a survey, which is at the end of, it'll show up here on your screen. You can also feel free to email the presenters individually as well, if you have questions. So right now, coming up on your screen, I believe the survey, yep, that's the survey, and you can go ahead and if you mouse over, if you hover over the survey, you can click on it, it'll take you directly to the questions. It's very quick, very short.
Yes. This is Jeff Lamondia.
Yes.
I answered one question in the text box here. There was another question that came up about the Human Transit book and where they may be able to access it, open source.
You wanna go ahead
I
and,
wasn't able to respond. Can you hear me all right?
yes, do you want to go ahead and talk about those two questions, just in case anybody has interest?
Sure. Well, I answered the first question about the post-class surveys we did, and it was actually kind of a pre- and post survey we did comparing how well they learned the material. And we improved the course materials based on those results. What they got, we figured we did pretty well, and what they didn't, we tried to improve. But then the Human Transit book is by Garrett Walker, and we have our students read it through the Google Books website. If you just books.google.com and search for Human Transit, all the material is right there, so they can read it online from that. But if you don't have access to that, you can also go to his website. Many of the articles that show up in the book are actually on his blog as well, so both would work.
Wait a second.
Sorry, I don't know who asked that question, but
my survey, I just received an email from Scott Washburn that the survey link is not working, but if I click on it, it works for me. Is that, can anybody go ahead, Emily, if you're on, can you go ahead and click on it and let me know if you can access it?
Yes, Inez, it works for me if I click on the
Oh,
link.
it's working, okay.
Yeah, I just tried clicking on the link in the slide, and
Oh, okay, because
now it's churning for me.
okay.
Okay. The first time it just said, yeah, it couldn't connect.
Okay.
Okay.
Well, if we don't have any other questions, thanks to everyone who participated in this webinar. We hope you found it useful. And thank you very much to all the presenters for taking time out of your day to showcase all your educational products. And thank you very much. And have a great day, everyone. Bye-bye.